It's nice to see you all here. This is Jocelyn, and I'm so excited for today's episode of Success Inspirer for UCC Robotics Club. Let me introduce to you our special guest for today. He is the public face of TensorFlow.js, helping web engineers globally take their first steps with machine learning in JavaScript. He combines his knowledge in the technical and creative worlds to develop innovative prototypes for Google's largest customers and internal teams. He has been a hybrid engineer for over 15 years, working within web engineering and investigating emerging technologies, combining his passion for several areas including both front and back end web programming, but also design and user experience. He has worked in many sizes of companies from startups, including founding his own to Google. Jason has a Master of Engineering degree in Computer Science at the University of Bristol, England, where he specialized in reality mining and invisible computing. A certified information privacy technologist and a member of the British Computer Society. Let's all welcome Google Senior Developer Relations Engineer for TensorFlow.js, a good friend of mine, Jason Mays.
Thank you for the lovely introduction there. It's nice to see you all here today. It's a pleasure to be talking with everyone, and I look forward to seeing what questions you have in store for me. And of course, yes, I currently work at Google as the Developer Relations Engineer for TensorFlow.js, but happy to answer questions about Google in general, or career, or life, whatever it might be. So open to possibilities there. Thank you.
Right? Perfect. Nice to see you again. And I believe this is also the first time for most of our team members to meet someone who's a Google scientist. So really grateful for this opportunity. And before we begin with their questions, I know they have a lot right now. Allow me to first introduce to you our robotics coaches. Let's begin with Sir Ram. May you please introduce yourself? Thank you.
Hi, Sir Jason. I'm from Morales. I'm the robotics specialist here at CCT, and I'm currently training these children, these students right now. They're up for a competition that will be held next week. So I really believe that this talk will encourage them or inspire them to make more robots and to be a future software scientist similar to you, sir. Thank you.
Excellent. Nice to meet you.
Thank you, sir.
All right, thank you, Sir Ram. Let's have Sir Limwell.
Good afternoon, sir, and good afternoon, Ma'am Joyce. Thank you for that introduction. So, I am Mr. Lemuel Ramos. I am currently faculty teacher here at UCC and a robotics trainer and also a science teacher here. And I am also a parts and some basic knowledge about basic programmings and also a hobby and specialist, sir. So, that's all, and thank you.
Lovely. Pleasure to meet you too. Good stuff.
Thank you, Sir Limwell. Last but not least, we have Sir Kier.
Good afternoon po everyone. My name is Sir Kier Nabananasi. I've been
No worries. Sir Kier is currently having difficulties with his internet connection. All right, so let's continue. Jason is here and is very much ready to answer all your questions. You may use the chat box or unmute your microphones whenever you're ready. So it's going to be the first one. Let's begin.
Sir Jason. So as I've mentioned before, these students of mine here in the meeting are are from our robotics team. And when I was asking them to introduce themselves, they were very keen in software development. I believe here wants to be a software engineer. So these people here are still at high school, at junior high school. So I would like to ask, what kind of strand did you took for senior high school or at your later years at high school, and what courses or course do you recommend these children for their college career?
Sure. Yeah, I think the main thing is to get experience in programming if you're looking to go into a software engineering role, of course. And even if you're just doing that on the side, I'm not sure if you have an official coding class at your school or not, but if you do, that's great. But if not, I actually started myself just in my spare time learning, I think, Visual Basic 6 back in the day, many, many years ago. And of course, I look back at that code now and it was terribly written code, but you've got to start somewhere. And the main thing is to be curious about the world around you and start to make projects that you're interested in. And don't worry too much about getting it perfect the first time, especially when you're younger. But the main thing is that you're creating things that you're interested in. So maybe it's robotics, or maybe it's some problem you're trying to solve using new technologies that you're aware of. But the main thing is to make something new every month, every week, something like this. And the beautiful thing about software engineering, of course, is that as long as you've got a computer, that's all you need. With robotics, you need some hardware, of course, potentially to use on the robot. But on the software engineering side, you just need to be able to, install some tools on your system. And in the case of JavaScript, you don't even need to install anything. There's websites, you can do everything in the website these days. So the whole text editor is right there. So I think practice is the key there, and start building your portfolio early. It's never soon enough to start building your portfolio. And even at Google here, you don't actually need a degree in computer science to work at Google. It certainly helps. It can help you get into Google versus competition, of course, but it's not required. And if you actually have a very strong portfolio to show that you're working at the same level as a Google engineer, then that counts just as much if you're well known and respected in the field with your following on LinkedIn or something like this, and you're talking about this industry stuff all the time. And I think that's the other thing that brings me to my second point. When you're learning about this stuff, share your knowledge with others too. Often other people want to learn, and they might be in the same stage as you, at the same point in life, learning how to program. And the problems that you have when you're learning are probably applicable to many other people too. So if you start blogging about this or sharing your experiences on social media, that kind of stuff, that can help grow the number of people who respect you in that field. And of course, by the time you're 25, whatever it might be, you'll then have quite well respected in that industry for doing the things that you're doing. So those are my tips there. Yes.
Thank you so much for that wonderful tip, Sir Jason. I hope my students here are inspired by your answer. Now, I have here another student of mine. His name is Prince029. He asked a question. He asked, how often can machine learning be used in current state right now?
Yeah. That's a great question. And machine learning, for those of you who are new to this area, essentially is a way of getting a computer to learn how to solve a specific task by itself, essentially. So you'll write a program once. Let's say you write a program that allows you to recognize objects. But the beauty of machine learning is that you can use the same code to then recognize any object just by providing it with different input data. So if I want to recognize apples, I have lots of images of apples and I feed that into the system, and out comes a model, as it's called, a machine learning model, that then understands how to recognize apples. Now, if I wanted to recognize a dog or a cat, I just feed in different images of dogs or cats instead. And that's very powerful, and it's very different to how we used to program in the past, where you would have conditional rules that you explicitly define as a programmer to look for certain shapes in the image to recognize the apple and certain colors and all this kind of stuff. But there's only so much you can do with that rule-based system, because if something slightly changes, or you get a different type of apple or a different breed of cat, it's going to break right away. So machine learning, for that reason, has become very popular. And the reason it's become popular is that These concepts actually go back to the 1950s and 1960s, but it's only now that we have the processing power with the new graphics cards and the new CPUs in our desktops and laptops at a good enough cost that everyone can access. So that's why we're seeing an increase. And because of that, pretty much every industry out there is using machine learning in some shape or form. And just in my role alone, I've spoken to companies in the healthcare industry. We just recently partnered with someone who uses one of our TensorFlow.js models to recognize the pose of your body. So it can tell you how you're standing, if your arms are out and in, all that kind of stuff. And with that information, they can do remote physiotherapy at scale. So physiotherapy is like if you've got body condition where you can't move properly, they can actually analyze your range of movement remotely. The doctors and nurses can do that all remotely now. And you can use the machine learning system to kind of grade you on your exercises and routines and things. So we see a lot of interest in fitness and healthcare. And of course, other areas too. So the object detection stuff like I just spoke about, but there's also areas in natural language processing to understand human language itself. And many other things that the industry is moving so fast. But essentially, the short answer to your question is it's being used everywhere. And this is a great time to get started. And the team that I represent does machine learning in a language called JavaScript. And most of you probably know this as a language that's used to build websites. However, we also do machine learning in JavaScript, and there's some benefits of doing it in JavaScript, in fact. And one of those things is that it's really easy for everyone to try out, because I can just send you a link right now, and everyone here, assuming the internet is working, you can go to that website and you can then try what I've created. Very easy to share, very easy to use, and there's no need to go and install Linux, install some custom code, custom dependencies, get the environment set up just to try something out. So for that reason, we're seeing a lot of interest in TensorFlow.js right now, which is the team that I represent. And there's other things as well that I won't bore you with, but there's other possibilities of why you might want to use it on the device rather than in the cloud and the server, in case you want to run offline and that kind of stuff too. And as you are a robotics course here as well, TensorFlow.js can run on the Raspberry Pi via Node.js on the Raspberry Pi. So if you are using a Raspberry Pi or something like this, you can actually run TensorFlow.js there too. Just want to point that out. So I hope that answers your question.
Thank you so much, Sir Jason. Honestly, I actually use my Raspberry Pi for my thesis. For that, it's an image processing thesis. I've used OpenCV instead.
Nice.
OpenCV on Raspberry Pi. So that's for the image processing part. Thank you so much. I have here another question from a student of mine. Her name is Shanti. So she asked, what do you always keep in mind when programming? So these are starters. They are starting to program their own robot. So they're very curious.
Yeah, thank you for the question there. What do I always keep in mind when I'm programming? Most of the time, I'm trying to figure out how I can evolve the idea that I currently have to be something more than I initially started with. So let's say I want to get something working for object detection. Let's just start like this. Okay, I'm going to make something that can detect an object. And I start coding this, and I start writing the program, and it starts working to some level. And then I'm like, well, how can I make this useful? How can I solve a problem in my life using this technology? So once you know the limits of the technology, like, okay, it works in these conditions, or it doesn't work so well in these conditions, you know what the limits are, and then you can have a better understanding of how you might want to use it. So the second step is to then kind of get your creative mind thinking. Actually, programming is very creative, even though people associate it with being technical. That is one aspect, and yes, math is involved, but actually programming can be a very creative process. And I'd encourage you to engage your creative side of the brain to think about how you might use it to solve real world problems. So taking the object detection as an example, maybe if I can recognize where my dog is and where my couch is, the sofa, I can know when those two objects overlap. And then I could send myself an alert when my dog has got onto the couch or something like this. And in fact, I made exactly that example just a couple of months ago, and we posted this on our YouTube channel for people to watch. And it's a very simple concept, but I've taken something that was just doing nothing, just recognizing random objects, and then turning it into something useful. And I think that's the key step you need to take in your mind is don't just make something for the sake of making it for an engineering project, but actually make it to solve a real world problem. And if you do that, again, you'll probably find other people have that problem, and it could be useful. It could even be turned into a business. And this is a good way to get thinking early on, especially when you're younger, to kind of train yourself to think like that. And then it gets easier over time as well. So definitely think creatively when you're programming, and think how you can improve what you've got. Programming is never finished. There's always ways to improve things as new technology comes out or new ideas come, or think how you can combine technologies as well. So maybe you're expert in robotics, but maybe you're also just interested in music. Can you combine the two worlds together somehow? Who knows? Maybe you can. And if you just think about it a little bit, you might be able to do something interesting there. So, yeah.
All right. Thank you so much. So Ram, I think there are other questions here in the chat box, but we would like to also hear it directly from them. So, yeah, let's have the next one here.
Sure, let me call on Ricardo, Princess. I know you're in there. Can you please read your question and tell it personally to Sir Jason?
Right.
Okay, so hi, Sir Jason. Hi, humans. Some people hate technology, especially robots, just because they think that robots replace humans' work. So how will you encourage those people that robots are actually helpful in today's time?
Yeah, that's a very interesting question. And I think this actually happens in a lot of other industries before. If we just remove robots for just a second and go back to the very early days when airplanes did not exist, okay? And everyone went around the world by going on a ship. Now, when airplanes came along, people were like, well, where are all the shipping jobs going to go if the ships are displaced and everyone's going to fly in airplanes? But of course, new jobs are formed because of that too. You've got air hostess, you've got the ground crew, you've got the check-in staff, you've got the people who invent the airplanes and make the airplanes, all the related industries that create the entertainment systems for those airplanes, all that kind of stuff now exists because of that transition. And I think the same kind of logic can be applied as well here to the robots industry. So yes, the robot might replace some jobs, especially those that are very repetitive. Like if your job is to screw something into some part of a factory line for producing some object, that will probably be replaced by a robot at some point in the future because it can work 24/7 and probably cost a lot less to do. But that doesn't mean you cannot find other opportunities. Maybe the robots themselves require maintenance, or maybe they need to be installed, or maybe there's software you need to write for those robots, and there's other things that will pop up because of that, including the manufacturing of parts for those robots. So maybe, there's other things that could exist essentially. So it depends on the industry and the exact job that you're referring to, of course. But I think we as humans will have to evolve slightly to work on higher level tasks. The more creative thinking is harder, certainly, to replace. If I asked a robot to paint a painting, technically it's possible. I've seen this done actually, but it's much harder to make something like this than to kind of replace something that is a repetitive task, for example. And I would also argue that humans doing the same thing that is, just screwing something in, it'd be better for those people to do something more useful with their time as well. And I think we're starting to see around the world countries investigating universal basic income and these kinds of ideas as well, where humans are given, because of the automation, a certain base level of income for free, because the robots are so productive, they can actually sustain food and shelter for the people, so to speak, at that point. So obviously, this is like many years into the future, but I'm just thinking into the future here a little bit. And it'd be interesting to see how countries adapt. And it will be a change, and things will have to change, and people's way of thinking will have to change. But I think that other opportunities will come from that as well, just like it has done in the past, and will continue to do so in the future as well, with other industries that come up beyond robotics in the future as well.
All right, cool. And so we have another question here from our very own coach, Sir Pierre.
Good
Is your
afternoon po.
Hello there.
And
Yeah.
hi, good afternoon. My question is about AI. So with the current AI that we have, from your perspective, how far are we from AI like Jarvis from Iron Man? Just, just
Great
a
question.
curious question. Thank you.
So essentially, right now we're in a world where we can do something called narrow AI, and all that means is that we can do a certain task or maybe a few tasks as good or better than a human expert in that field, like the object detection that we saw. So there's actually people researching into brain tumors, for example, and taking the medical scans, and they can use an AI system to actually have better accuracy at finding those tumors in the grainy medical images than the doctors. And I think the next few years, we're going to see like AI plus humans working together as the sweet spot. That's where the most return of investment will be for many decades to come. In answer to your question specifically about general purpose AI, which is what something like Jarvis might be, I don't think we're there anytime soon. If you look at how AI works these days, or more formally machine learning, it's just a bunch of mathematics, and it's literally multiplications and additions, all working out in a very big graph to then kind of give you some predictions based on statistics and that kind of stuff. So when you look at it like that from a pure mathematical perspective, I don't see how that is going to be a general purpose AI anytime soon. It's not conscious in the same way that you and I are conscious. So there's definitely something missing there, and as humans, we don't even know what consciousness really is. We're still investigating those areas as well. That's a much deeper question. And to replicate something like that would involve much more than we have right now. And I can't put a timeline on that, unfortunately. That is beyond my scope. But I don't think we're going to have anything like that. Certainly not in the next decade. I don't think that's going to be possible with the limitations of technology that I've seen right now. And also our understanding of the human brain is just not advanced enough either to do that right now. We've only just managed to map like a 1 millimeter cube of mouse brain, let alone the whole human brain. So it's very, very early stages right now.
There you go. Okay, thank you so much. And let's have the other one. Joaquin, Gabriel.
Hello. So, I would like to ask, what made you interested in programming?
Yeah.
What inspired you?
Great question. So actually, my story started with me wanting to join the Royal Air Force in England. I was actually very interested in aviation back in the day. And due to various medical reasons, I couldn't actually end up becoming a pilot in the Air Force. So my uncle bought me my first laptop computer when I was a teenager, probably like, I don't know, 12, 13, 14, something those kinds of time frames. And I started dabbling in technology and just kind of seeing like what exists and how to use it to do my own things. And that's where my curiosity started, essentially. And it's around that time I started investigating programming. I think I did a bit of JavaScript, a bit of Visual Basic, those kinds of programming languages. And I was able to make applications that, I found useful, and I could do whatever I wanted with them. And of course, the first time you make a computer program do something that you actually want to do, it's a very empowering moment. You get really excited by it. And of course, that inspires you to keep exploring further and to go deeper into that field. So that's where my curiosity started. And, I then, throughout my high school days, I essentially got better at programming. But it wasn't until I went to university and studied computer science where I got the more formal training that I needed to be much more proficient at it and efficient, and thinking about security, scaling, writing code in a good way. And, you learn all these things as you get more familiar with it. But that's basically the journey I took. So it started by not being able to do something. I then went down a different path, and then I got very curious about it. And of course, technology was like kind of really growing in the 90s, which is when I grew up. And in the 90s, this is when all this stuff was coming together with the internet, and all this kind of stuff was happening. And of course, that opened up a whole bunch of things that I could see a very bright future for. And I think you're actually in the same place I was in the 90s, but with artificial intelligence and machine learning. You're at a very unique point in life right now where you're at the beginning of an industry. For me, it was the internet when I was a kid. The internet was just starting when I was a kid. And if you got on that at the right time, you can be, the experts of tomorrow. And I think the same thing is happening now with machine learning. You're in a very good position to start learning machine learning right now. So, in another 5 to 10 years' time, you'll be the experts in machine learning and AI for robotics or for TensorFlow.js or for whatever it might be. And I think this is a good time to get involved in that stuff right
now. Okay. And let's have another one from Princess. This is about website making.
So nowadays, I'm very interested in website making. So how will I make my website discoverable?
Yeah. So essentially, when you look at how famous search engines work, like Google, for example, it's all about what websites link to you and how influential those websites are. So if you have lots of your friends' websites linking to you, it counts for something, but not as much as, say, if a famous news website was linking to you. And depending what they're linking to you for, so if in the link it says, check out this website for programming knowledge or something like this, those words actually count for something too. So there's a lot of things that are taken into consideration from the links themselves and who is linking to you. This is something known as PageRank. It was invented by Larry Page, the founder of Google. And essentially, it ranks the websites based on this kind of popularity scoring. Now, the exact algorithm is not revealed to the public, of course, but, that high-level understanding I've just given you is the gist of it, which is publicly known. And it's all about voting for people, essentially, using other websites. That's how it, at its core, is working. Now, obviously, when you're earlier on in your career, it can be hard to have the contacts who are from influential areas to link to you. So there's two ways to go around that. First of all, writing good content in itself will help you allow people to find you and then link to you. But secondly, writing good content for other people, for example, on a magazine or blog of someone else who's already famous or doing well, that can allow you to then link back to your website from the article, which then increases your own page rank as well, essentially. So basically, the gist of it is to prove that you're a knowledge expert to others by sharing your content on more sites. And this is where social media can actually help here. On professional websites like LinkedIn, Microsoft now owns that, of course, and they can understand all the content on that site very well and surface it in their search engines very nicely as well. And if you start posting on these things, you start to associate your name and brand with the things that you're talking about. So as long as you're consistent and keeping on track to the topics you're passionate about, so maybe you're interested in web design, then talk about those areas every single week, at least twice or 3 times a week. And you do have to put that much effort in. I've been on LinkedIn for how many years? At least 10 years, maybe more. And I just broke 10,000 followers on there. But it's taken me 10 years to get there. And that's without using any paid advertising, right? I didn't use paid money to do that. That's just organically grown. And I'd argue that organically grown is usually better quality people who are following as well. But you can also look into advertising as well. If you have any money, you can also do paid ads to get people to come look at your content. That's one way to kind of boost your initial kind of follower count and that kind of stuff. But, you've got to be careful there. You've got to see, are those bots? Are they real people? Are they actually engaged with your content? So you've got to be careful on those things. But if you get your organic following to just grow because you're writing great content, then people will naturally find and come to you. So,
All right. So I think we have still one more question here in the chat box from Shanti Grace.
Good afternoon, sir. It is a pleasure having you. And I would like to ask, what or how did you feel when you made your first successful program or code?
Yeah, that's a great question. I don't actually remember what my first, actually, maybe I do. The first thing I ever tried was making a website back when the internet was a new thing. And I think all I actually did was I wrote some HTML and I put a GIF on the page, an animated GIF, and a title. And that was it. That was like, the extent of my programming when I was 12 or however old I was. And I thought I could do anything in the world. If I can make an animated image on the screen, then I could do anything. And of course, now that I am much more experienced in these matters and animated GIFs are just everywhere on social media, there's nothing too special about that these days. But back in the 1990s or whenever this was like cutting edge stuff. So obviously, I think the equivalent for someone like yourself these days is take your first step to say TensorFlow.js to recognize an object. That's your new hello world of programming in today's world. That would be, oh wow, I got superpowers. And you really feel like you've got superpowers, and then you just got to use those superpowers for good, and you can make great things. And I can show you anyone here today how to recognize an object without writing a single line of code. There's a great website called teachablemachine.withgoogle.com. I'll just write it in the chat so people can see it. 1 second. One moment. Give me just a second here.
Sure.
If after this you'll go to this website that I just put in the chat, and feel free to save the link because when you leave the Google Meet, it will disappear. Basically, if you go to that link, you can use TensorFlow.js in the browser to point your webcam at things. You take some sample images, you point it at a different object, you take some sample images, and make sure you get roughly the same number of sample images, around 30 or so. And then you click on the train button, and it will kind of make your computer fan spin up for a little while. And then after a couple of minutes, it will show you a live preview on the right-hand side. And when you point it at object 1, it will say object 1. If you point it at object 2, it will say object 2. And in less than 5 minutes, you can make something that can recognize objects. And you can imagine how you might use that with a robot, or you might use it for something else as well. Whatever your idea might be, if you control a Raspberry Pi, you could recognize the car coming into your garden, and you can automatically open the gate with a servo or something like this. So it's really up to you what you might do with that knowledge. And I encourage you just to play and explore these things and have your own, oh wow, I can do these kinds of things moments. And that's where it all starts for me. Obviously, back in my day, things were much simpler. Teenagers these days have so much more technology at their fingertips than I had when I was a child. But this similar kind of aha moment will happen for you as well, using something like machine learning maybe. And I think if you just try it out and feel that like, oh wow, I can actually do this moment, then you'll see that kind of evolve into something very nice. And just keep up the peeling away the layers of the onion, so to speak. And sometimes you will cry, the onion will make you cry, but all the maths is behind the scenes there, waiting to get at you. But you can start high level and still get very far. And just peel back the bits you need as and when you need them. And if you keep at that, do it every week, every month, you'll be very knowledgeable very quickly. And you'll be well on your way to becoming a machine learning engineer or robotic engineer, whatever it is you want to do. So, yeah.
That sounds good, right? Okay, well, we have a lot of not really few, but a lot of random questions here.
Yeah, feel free.
One is that tell us about a time you have to persuade someone with your new creation.
So actually, yeah, that's a good question as well. So my previous role, so I've never been a software engineer. I've been a web engineer, I've been a creative engineer, and I've been a developer advocate or developer relations engineer, as it's now called. And I'd encourage you all to think about other roles that are not just software engineering, because there's a lot of exciting roles out there that you might want to consider, like I did. And in my creative engineering role, my duty was to explore emerging technologies. So at the time, it was things like augmented reality, virtual reality, machine learning, maybe learning to use some microcontrollers and things like this, and trying to figure out how I can use them to tell the story of the big companies that Google works with. So I can't say all the names of the brands, but you can imagine a big name brand that I probably worked with them at some point, and would have to try and tell people how we could use technology to tell their story. So in order to do that, I had to come up with a prototype and then pitch it to the company and say, hey, you should make this prototype because of X, Y, and Z. It's going to be attractive to this kind of audience or demographic, whoever it might be. And it will cost this much, and you can do this kind of return. And yes, so selling your ideas is very important. And actually, I was reading a book recently on Twitch. I just started on Twitch. I'm not a big Twitch user, but I just started on there. I've been reading this book called The Myths of Innovation. And I was reading through this because I obviously have worked in innovation in my last role, and I was giving my own commentary on each chapter as I was reading it. I was giving my own thoughts and opinions on there as well. And I have to say, overall, there's some good knowledge in this book about why ideas fail, why people would accept your ideas, all that kind of stuff. And it might surprise you why that is. It's not always that your idea is bad. It's just because other people aren't willing to take a risk, or maybe they just don't like you, or there's so many reasons why an idea can fail other than it being bad. But sometimes your idea can just be bad and you're in love with it. And that's also something you've got to look out for and be aware of in life as well. So there is a bias when you come up with an idea that you naturally think it's good. So you've got to do a sanity check there to make sure it really is good and it's not just your own personal bias getting in the way. But once you realize how to do that, there's various other techniques you can do to kind of check if it really is going somewhere. Then you can look out for the other red flags that are written in this book as well. But I've digressed there slightly, gone off track, but hopefully that answers your question somewhat and it's helpful.
Right. So he's not just a creator, but also a marketing strategist as well.
Yeah, that's a good way of thinking about it. That's very good. Yes. A lot of famous inventors like Nikola Tesla, very, very intelligent person, great inventor, but a lot of other people who are better at business stole his ideas and put them to market, like the guy who did all the light bulb stuff and all this kind of thing. So was it Edison? Someone stole his idea and made it profitable, and he just didn't, because he was interested in the science and the technology, and he was just not good at selling it to the people. And unfortunately, he died a poor man, which is unfortunate. He had a great mind, but you do need to, in this world, you need to know how to market your idea as well. It's not good enough just to have a great idea. You have to sell it to the people as well. And that's hard to do. So, if you're starting a company later on in your life, find people who have complementary skills that can help you. So maybe, yes, you're on the robotics course right now, but maybe you can team up with someone on a marketing or sales course, and they'll be your co-founder, So try and have friends in diverse areas. That also helps to diversify things. Yeah.
Right, exactly. So another question is, what's the biggest challenge you have experienced as a Google scientist, and how did you overcome it?
Biggest challenge. There's a lot of challenges at Google. I think every day there's some kind of challenge going on. I think in my current role, it's knowing how to manage my time well. Currently, I'm the only developer advocate globally for TensorFlow.js, which means a lot of people ask me for presenting at conferences or writing tutorials or whatever it might be. And there's only one of me, and there's like 10,000 of them. So obviously, I can't please everybody. And you've got to choose what you can work on wisely, essentially. And time management is very important. Knowing when to say no is important as well. Being British, I'm quite polite typically. And I was like, oh, yes, I'd love to get involved. I'd love to do this. I'd love to do that. But I very quickly realized in this role that I cannot keep saying yes to things. And I had to get much more stricter on those areas. So refining those kinds of skills are very important. And if you get, I get like several hundred emails every day. And my email filtering skills on Gmail are now very, very good. And I try to keep my inbox to under 100 emails that are unread at all times. And I set aside times during the day to do that. And this is a very important thing as well, because one thing you'll notice as you get more busy in life is that you'll feel like you're doing work because you've got lots of emails coming in. But then at the end of the day, you realize you didn't actually do any work. You were just replying to emails or checking them. And that's not work. That's kind of shallow work, if you will. It's just kind of maintaining emails, which is not real work. You need to put time aside to do the deep work. And to do deep work, you need to put aside like 2, 3, 4 hours of solid block of time without interruption to go into that state of mind that I'm sure many of you are aware of if you're programmers already, that you get to the zone, so to speak, and you're in a good state for programming. And if you're interrupted, you just can't be productive. So what I do is I check my emails at the beginning and at the end of the day, okay? And in between, I just won't look at it. If something's really urgent, someone will phone me, or they'll do a video call or something. If it's not urgent, it can wait until the end of the day or the next day. So that's how I deal with that. And I recommend that everyone tries doing that in their lives too, because I think in this generation, there's so many notifications on Instagram, Facebook, LinkedIn, Twitter, whatever it might be. there's too much, and none of it is useful really. It's just people liking a post, and you don't need to know about that, honestly. So just get rid of as many of those things as you can, and focus on the real questions that matter or the real work that matters. Yeah.
Right. Practical advice from Jason, right? And that's also one of the reasons why you guys are very lucky that you have the opportunity to be able to meet him personally. Okay, so now another question is, tell us about a time you failed or made a mistake. How are you able to manage difficult moments successfully? Oh.
Yeah, that's a great question. Let me think about this for a little bit. Where did I last fail? Well, I guess like one of the more interesting ones was when I graduated. I joined an investment bank, and when you're at university, a lot of the companies come to try and recruit you before you've graduated, so that they can kind of steal the graduates before they've had a chance to look at all of the other job opportunities out there. And obviously, when you're younger, you can be a little more naive, and you're like, "Oh yeah, this looks great. It sounds like a big company. I'm going to go join that thing." Turns out, I went to the introduction day, and I didn't like the atmosphere there, which wasn't my kind of people. So I quit after the first day. So I didn't have a backup plan. I had a lot of student debt for my university fees, and I had no plan B. So in that case, I kind of failed in terms of my career goals momentarily. But I also believe that you've got to do what's right for yourself as well. And I then managed to join a startup company who was my ex-head of computer science at the time, who was looking for someone for web engineering. And I managed to join a startup called Xmos that was a semiconductor company. And I got a lot of experience and knowledge there. I just would not have got that at the large investment bank. So I managed to wear many hats. I got to try digital marketing, photography, graphic design, web engineering, all these things, because startups are very, very interesting like that. And but I managed to turn that failure into a learning path for myself. And I think the main thing is that when you do fail, you learn from it and then move on. If you fail and then you just get angry and shout about it and not learn anything, that's not constructive. I could have quit and then be like, oh, I'm just gonna be angry about it and like sad for like months or something. I don't know. But if you do that, you're gonna get stuck in a hole. So make sure you kind of learn from that experience. From that experience, I learned how to do interviews pretty well. Interviews are pretty tough to get into investment bank. I learned about what they wanted on their team. I learned about salary negotiations and this kind of stuff. So I used that to my advantage to then negotiate my role on the startup, for example. So learn from those experiences and turn them into more positive ones for yourself. And of course, that ultimately led me on my career path to Google. So I'm happy that I actually went that way in the end. So yeah.
Right. And so another question is probably just a follow-up question. How many companies have you worked for? Why did you choose Google?
Yeah. So technically, my first job was at my high school. I actually hacked my high school and they offered me a job as a head of network security. And I used that job to get some money to allow me to go to university. So technically that was my first job, was the head of network security for my high school. And I'm not suggesting that you do that. That was a one-off, that it worked out somehow. But I don't recommend hacking high schools anymore. But basically, that was my first job. And then at university, I was also a lab demonstrator to first-year students, which I was paid for by the university. I also got some part-time work at a web startup. So that's 3 roles. After that, I joined the semiconductor startup. That's the 4th role. After that, I did my own company. That's the 5th. And then after that, at Google. Now, I've been at Google for 10 years. And at that time, I started as a web engineer. I then changed positions to creative engineer. And then I'm now developer relations engineer. So in total, I've held 8 jobs. 3 of which were at Google, but they were technically different jobs. So 8 in total over the course of about 15 years, roughly. So, it's good to move around. And I think for me, after 3 years, you tend to get kind of curious about other things. Because 3 years is a good amount of time. You kind of know your role really well. and you're starting to explore other areas at that point. And then sometimes things naturally fit in. So my average job time is about 3 to 5 years per role, roughly, depending on the role and job type. But yeah, something like that.
Wow. All right, and have a few more questions here in the chat box. Let's have Princess Rishan.
So hi again.
Hello. Yeah.
My dream is really to become an engineer, but I'm still not sure what field I want to take. That's why I'm exploring robotics and anything related to engineering. So if I'm going to take computers engineering for college, what school do you recommend? Because I'm soon to be migrating in Canada. So if you could recommend any schools in the US or in Canada, it would be a great help. But if you don't have any specific school in mind, what facilities or programs we need to look for?
So I'm actually from England originally, so I'm not very knowledgeable about US universities. But honestly, like the US education system is very expensive, and I question how much advantage you get over going to other schools. As long as you got the degree, that's kind of a check on the box as far as any employer is concerned. Obviously, the more reputable ones get a bit more kind of hype, but as I said before, if you've got a strong portfolio and you're showing that you're able to write code at the same standards as everybody else, it doesn't matter. And I'd go wherever it makes most sense for yourself. And a question for you actually, what are your interests right now? Like engineering aside, what do you like? Are you interested in music? Are you interested in design? Like what are your hobbies? Just let me know that and maybe I can help shape your future there.
So now I'm really interested in chemistry and engineering.
Okay, yeah.
Cool. So I'm really looking forward to aviation engineering, computer engineering.
Yeah, and I think this is a very powerful combination actually. So given that you enjoy chemistry on the side, then like thinking about how you can apply that kind of stuff in your final year thesis for your degree as well, like applying computer science to chemistry to solve a problem in that domain would be very useful. And also, if you're interested in that, that helps a lot as well, because you're going to spend many, many hours doing that. So it's always good to kind of choose something that you have interest in. And the other thing is when you graduate, even though that you might be at the beginning of your career with little experience, you've got knowledge in a domain that overlaps two industries. And that's where it's harder to find people. If I'm looking for someone who is good at chemistry and computer science, there's very few people in the world that overlap those two industries. I can find lots of software engineers. There's like literally thousands of them here in the Bay, very competitive. But if I need someone who's chemistry and computer science, it's immediately a much smaller subset of people, which makes you more valuable in a way. So you've still got the computer science skills, you've still got the chemistry skills, you can still do both individually if you wanted, but having them both together and knowing how to apply them together by proving it in a final year thesis or a research project or something at university shows you can merge those industries. And depending on where you end up afterwards, that can be advantageous. So if you end up working for a startup that's doing something with chemistry and needs a tech mind to make it happen, you can actually have an advantage there in those kinds of companies. So, and I do recommend looking at startups after graduation because when you're younger, it's much easier to take a risk, and sometimes that can play out very nicely as well. Startups can potentially grow to be very big, and you can really own and shape those companies at those early stages. So earlier on, explore startups, explore those kind of areas where you can combine industries together. And then later on in your career, maybe when you're in your 30s, then, maybe look at the Googles and Amazons and Facebooks of the world where you want to have a more stable career at that point. But maybe the startup was successful and you don't need to move at that point. Who knows? But, I explore these kinds of options earlier on. It's my recommendation. Yeah.
Right, thank you so much. So another princess would like to ask you something. So let's have Princess Sata.
Good afternoon, Bob. What is the most innovative solution you successfully implemented in the field of robotics?
So the most innovative invention in robotics was that?
Yes, Bob.
So I think for me, there's a company called Boston Dynamics that you may have heard of that made the Spot robot or Atlas robot. And I think that they're a very interesting company. I believe I've not seen any robots that are better than those. This is my personal opinion. This is not Google's opinion, of course. This is my personal opinion. But like for me personally, the dexterity of those robots and how far they've come in the last 10 years is truly amazing. If you asked me 10 years ago, would robots be doing backflips and parkour and jumping around trampolines and things, I'd be like, no, that's just not going to be possible. But Boston Dynamics have managed to pull it off somehow. And I think this is a very interesting company to watch. And we're already starting to see companies in China replicate these kinds of robots now. I've just pre-ordered a mini robot that is kind of like the Spot robot for $500 on Kickstarter. And I'm hoping to use TensorFlow.js on that to make that one intelligent as well. But like, yeah, this industry is moving very fast. And I think another 10 years from now, I'd be very interested to see where it gets to. But I think the thing I'm impressed with most is how well formed they are in terms of moving their various parts and actually keeping their balance even on when they've only got two legs and things like this, which was very, very hard to do just 10 years ago. So I think with the advancements there, we're going to see a lot more of these kinds of things in society as well. I've seen a number of robots around San Francisco just doing their thing. I've seen robot chefs in San Francisco, which are these robotic arms that actually cook you the meal and this kind of stuff. So this stuff it's coming. So even chef job might be up for debates in the future with these robotic arms making our meals. But yeah, very interesting time and a very exciting time to start exploring these and combining these robots with machine learning to kind of do these tasks even better than they could before.
All right. And so I think this is going to be the last two questions that we can entertain today. Mr. Jason Mays, where do you see yourself in 5 years? Oh.
Oh my gosh, I'm on the spot now. That's a good question. I mean, right now, I've been on the TensorFlow.js team for almost 2 years. So there's a good chance I might still be on the TensorFlow.js team because I'm really enjoying it right now. And hopefully I've grown the TensorFlow.js community to be self-sustained by that point, and that might enable me to then look into startups again. Who knows? We'll see where life leads me. But Google has been very good to me, and obviously Google's pretty hard to get into, so I don't want to leave without good reason. It had to be a really interesting opportunity for me to leave Google at this point in my career. But never say never. Who knows what might be around the corner? But I think the thing that I'm most excited about is just seeing how technology will evolve in that time. Just in the period of 1 year to 2 years, the accuracy in machine learning models has increased so much in computer vision. Even the generative models, I can generate like pictures that look lifelike and realistic, and I can just type in a cat with a red hat, and it will generate me an image of a cat with a red hat. You can do that these days, and it looks realistic as if it really was a real photo. And if we're already there, and that just took 2 years to get to that standard, where is that going to be in another 5 years? I'm very excited to see what will exist then and how I can use those technologies. So back to the beginning of this conversation, always trying to think about how you can take what you know and combine it in new ways to make or solve some problem that you have, right? So I can't predict the future just yet, but maybe I'll figure out that, okay, the key things now exist that allow me to make something new, and maybe I'll be doing whatever that thing is in 5 years. I figured out something new that I can actually now complete. I often get inspired by sci-fi movies and things like this, or like holograms and all this kind of stuff. And that was one of my recent inventions. I made a teleportation kind of device to transmit my segmentation of my body across the internet and then recreate it in augmented reality with like glasses or phone. And I often get inspired by sci-fi to make these kinds of things. So maybe something like that in 5 years. Who knows? Yeah.
There. And one last message to all aspiring young developers and students out there.
Oh, okay. Let me think about this. Got to be inspiring. Yeah, I think just generally speaking, try and get involved in as much as you can early on, because When you get to my age, it's definitely a little bit harder to remember all the things. So make sure you just get to try as much as you can earlier on. Try a bit of robotics, try a bit of computer science, try a bit of psychology or other things. Just go a little bit out there and see how you can combine these industries together. And, keep practicing these skills. I think if you try something and you just stop, then, you won't master it well enough. So do something for at least a few months to really appreciate that industry or that thing. And that knowledge will stay with you for a long time. And 10, 15 years later, you might be able to use that little bit of information you had to actually create a new idea that no one else is able to think up. And this is the type of stuff I was doing in my previous role at Google, and it helped me a lot by having exposure to many different industries. And I was one of the only people on my team who could then put all that together to build something from a blank canvas. So practice those skills early on. Remember that technical courses are creative as well. Programming is creative and technical. And to remember that there's both sides of the coin to this. And of course, expand your network. Any company you make in the future, anything you create in the future is more than just one person if it's really something special. And you'll need people in other industries to help you make it successful. So start networking with people. Start building your LinkedIn profiles if you're allowed. I'm not sure how old people are here right now, but once you're allowed to join LinkedIn, start building your professional profile there and connect with people. Follow people that are interesting. Learn from people who you think are better than you, and you'll then naturally become like them. So hang out with people you want to be like, essentially, is my key message there. Yeah.
Wow, and we cannot agree with you more. So as much as we would like to entertain all your queries, Jason has to sleep. So what time is it now in your place?
It is 11 p.m. in San Francisco right now. So almost midtime.
So it's 11 p.m. So by the way, you can follow him on his social media accounts like Instagram, Twitter, Facebook. We're going to flash that here on the screen. So I remember the first lesson I had with him in programming. I was like a 5-year-old girl learning the basics. And you know what? I just feel like that burning passion in him and in everything he does. And he is also one of the most patient teachers I know.
For today, thank you so much, Jason, and thanks everyone for joining us here. I hope you guys are truly inspired with those words of wisdom. And do not forget to like this video, share with your friends, and subscribe to our YouTube channel. See you guys next time.